The disk method, which I just discussed, works great when the region that's being revolved is sitting on the axis of revolution. But sometimes there's a gap between the region that we're spinning around and the axis of revolution. And let me show you in the picture here, we're going to be taking this region that's highlighted in blue, and we're going to be revolving it about the x-axis. So you can see that there's a gap. This region is not touching the x-axis. What happens when you spin that around is you're going to have a three-dimensional shape, but there is going to be a hollow bit in the middle. When that happens, we use the washer method. And the way the washer method works, I'm going to show you the three-dimensional picture here. So imagine taking that blue region, looking at the three-dimensional shape here, spinning it around the x-axis. You're going to have an outside shape and an inside shape. And in the very middle of that, it's going to be just empty space. So what we're going to do is we're going to take much of the same concept as the disk method, but we need to account for the gap. So what we're going to do is we're going to look at the outer radius. So we're going to take the point that is farthest away from the axis of revolution and find that distance. And then we're going to look at an inner radius. That's the point closest to the axis of revolution. And we're going to square those and then subtract. And that's this method. So again, you just need to account for that gap. So you're going to take that outer radius squared minus the inner radius squared. In this case, it says we're looking at a region bounded by the curve y equals x squared plus 1. That's the bottom part here. And the line y equals negative x plus 3. That's this part up here, the top part. And it's revolved about the x-axis to generate a solid. You can see the interval here is -2 to +1. The outer radius is going to be a point on that line. The distance from there to the x-axis is just -x plus 3. It's that y value. The inner radius, that's the distance from this bottom curve to the x-axis. And again, it's just going to be the y value, x squared plus 1. So we're looking at the volume, which is going to be the integral from -2 to 1 of pi times, again, outer radius is -x plus 3, and we're going to square that, minus the inner radius, which is x squared plus 1. And again, we'll square that. Bring the pi in front. And if I take -x plus 3 and square it, I'm going to get x squared minus 6x plus 9. And that will be minus, taking x squared plus 1 and squaring it, I get x to the 4th plus 2x squared plus 1. Then I need to distribute that negative sign. And I'm going to kind of do everything at once here. I've got x squared and then the minus 2x squared. So x squared minus 2x squared is going to give me a -x squared. The -6x, there's nothing inside that set of parentheses that can combine with that. So I have a -x squared minus 6x. I'm going to kind of just tick things off here as I go. 9 minus 1, so that'll be plus 8. And then finally, minus x to the 4th. So we need to integrate this polynomial. And we can do that. We're going to have -x to the 3rd over 3 minus 6x squared over 2 plus 8x minus x to the 5th over 5. And we're going to evaluate that from -2 to 1. The negative 6x squared over 2 is just negative 3x squared. So plugging in a 1 for x, we're going to have negative 1/3. And again, this is going to be 3x squared, so we'll get a minus 3 plus 8 minus 1 to the 5th. And we do the same thing, but now with a -2. -2 cubed is -8, but there's a negative in front of it, so it's going to be a positive 8/3. Then we have minus, this is the 3x squared, so 3 times 4, so minus 12. 8 times -2 is a -16. -2 to the 5th power is -32. A negative in front of that gives us a positive 32/5. The remainder of this problem is a lot of just simplifying and combining some fractions here, finding common denominators. In the notes that I have posted to BlazeView, I have it worked out step by step, but I'm just going to go ahead and go straight to the answer here. I'm not going to waste the time in the video going through some basic arithmetic, but you're going to end up with 117/5 pi. I don't want to get bogged down in arithmetic. I want to show you how this washer method works. Now, the washer method, like the disk method, can be extended to regions that are going to be revolved around a vertical axis. So that's what we're going to look at here in this second example. It says the region bounded by the parabola y equals x squared, that's what's in red, and the line y equals 2x in the first quadrant. So we're looking at this region in here, is revolved about the y-axis to generate a solid. Find the volume of the solid. So this time we're revolving around a vertical axis, so we're going to end up integrating with respect to y. So the interval is going to go from 0 to 4. And this time when we look at the outer and inner radius, it's the distance from the y-axis. So in this case, the outer radius is part of this red curve, which is y equals x squared, but I need to rewrite this. So instead of y equals x squared, I'm going to write x equals the square root of y. So that's my outer radius. That's furthest from the y-axis. My inner radius is the line y equals 2x, and that can be rewritten as x equals y over 2. So again, here's my outer radius. The blue line is my inner radius, and it's going to follow that same format. The volume is the integral from 0 to 4 of pi times the outer radius squared, so that's going to be the square root of y squared, minus the inner radius squared, that's y over 2 squared, so we're looking at y minus y squared over 4. And when we integrate that, we get y squared over 2 minus y cubed over 3 times 4, which is 12. Again, we're looking at it on the interval from 0 to 4. So 4 squared is 16. 16 over 2 is 8. 4 cubed is 64. We have 64 over 12. And then minus, if we plug in a 0 for y, both of these terms are going to be 0. So in this case, it's a lot less arithmetic to do than the last one, so I'll go ahead and work this one out real quick. 64 over 12 can be reduced down to 16 thirds. 8 is 24 thirds, so we have 24 thirds minus 16 thirds. So we have 8 thirds pi as the volume.